over die grote klap, de Big Bang.
Before the beginning, there was nothing. No matter, no light, no space, and even no time. Then came the Big Bang. In it was born space, time, and our entire universe. We don't know why it happened, but all the evidence tells us that it did. The first few seconds of the universe were full of frenetic activity. At temperatures and densities beyond our wildest understanding, matter and energy continuously swapped roles. Light made matter, matter made light. By the time the universe was just 3 minutes old, it had synthesized its basic building blocks, hydrogen and helium. Our universe was born. The Big Bang is no mere speculation. 15 billion years later, radio telescopes the world over can tune in to the blast of radiation from that initial fireball, now cooled to just 3 degrees above absolute zero. This faint glow, which bathes the whole of space, is virtually our only legacy of the universe's violent past. Another legacy is the fact that the universe is still expanding from that vast initial explosion. And I'm standing at the birthplace of 20th century astronomy next to the telescope that made that incredible discovery. In the 1920s, this telescope, the 100-inch Mount Wilson reflector near Los Angeles in California, was the biggest telescope in the world. It was being used by a young American astronomer called Edwin Hubble, who had discovered that the universe was full of millions of galaxies, giant rotating star cities like our own Milky Way. Hubble began to measure the speeds of distant galaxies, and to his astonishment, he discovered that instead of staying still, the galaxies were moving away from each other with speeds of millions of miles an hour. He deduced that the universe must be expanding, carrying the galaxies apart. But if the universe continues to expand, it will grow colder and emptier as the star cities recede. Ultimately, this will lead to the death of our universe. Is there anything that could resuscitate the universe? What is the force that could slow down or even stop the expansion? The answer is gravity. Gravity is what made stars and planets happen. And stars were the sparks that rescued our universe from becoming an ever-cooling and expanding vastness. They keep the universe alive. Even after a star's death, its gravity ensures that its influence still continues. And astronomers are beginning to suspect that dead stars may even control the future of the universe. But what is gravity? That was a question that perplexed scientists and philosophers alike for centuries, until the answer was finally discovered here. This is Woolsthorpe Manor in Lincolnshire, the birthplace and the home of the great British scientist Sir Isaac Newton. And that, of course, brings me to the story that everyone's familiar with. In 1665, Isaac Newton was working in his study behind me when he glanced out into the garden and saw an apple fall from this tree. But his genius was knowing what made the apple fall. He realized that the apple and the earth were attracting each other with a force a force he called gravity. And he realized that the force was something that every object had. The more mass the object had, the more gravity it had as well. But his real genius was working out that gravity was a long-range force. Not only did it pull the apple and the Earth together, it also kept the moon in its orbit about the Earth and the planets circling the sun. What Isaac Newton showed was that gravity pervades the entire universe. Gravity is even responsible for the birth and death of stars. At the start, particles of dust and gas are attracted together, like the apple and the Earth. Gravity compresses the mixture into burning nuclear fuel as the newborn star starts to shine. Without gravity, there could be no stars. At the end of a star's life, when its fuel runs out, gravity controls its death throes and shapes its corpse. The star cools and blows off its outer gas layers. As its nuclear engine runs down, its core collapses under the force of its own gravity. The giant star turns into a shrunken corpse, an object too small to be seen by astronomers until the last century. And now we know that there are three kinds of star corpse: white dwarfs, neutron stars, and black holes. But actually finding these collapsed objects proved to be quite another matter. In the end, it was their gravity that found them out. Telescopes like this one at the Royal Greenwich Observatory in England had a major role to play in tracking down these corpses. This telescope, which is 100 years old, used to look at the stars and photograph them night after night and year after year, looking for the way that stars actually move through space. A lone star would follow a straight line path. But if a star has a collapsed companion in tow, then the gravity of that corpse will make it move in a very unusual way. And that brings me to a shaggy dog story about a pup. Sirius, the dog star, is the brightest star in the sky. Last century, the German astronomer Friedrich Bessel made a special study of Sirius. Over the years, he noticed that it appeared to be wobbling its way through space, as if it were being pulled out of position by some invisible force. He concluded that Sirius had a companion star in orbit about it. But why couldn't anyone see it? The answer wasn't long in coming. In 1862, the American telescope maker Alvan Clark turned a powerful new telescope at Sirius. For the first time, he spotted a tiny point of light next to Sirius. It was indeed the dog star's companion, promptly called the pup, but it seemed too small and faint to have any effect on Sirius at all. Astronomers were soon to realize that the pup had a very strange pedigree. From its pull on Sirius, they could work out that it was as heavy as an ordinary star. But the pup was extremely dim, and that meant it had to be very small. Faced with an object with the mass of a star like our Sun, but with the size of a planet like our Earth, astronomers christened it a white dwarf star. The pup was the first of many white dwarfs to be discovered. A white dwarf is the corpse of a dead star, the core of a star the size of our Sun that has collapsed under the force of gravity when the fuel finally ran out. It is revealed for the whole universe to see when an aging star blows away its atmosphere during its death throes. This corpse has some bizarre properties. A white dwarf is so compressed that a sugar cube made of its material would weigh a ton. But once a white dwarf forms, it's downhill all the way. It has no energy source. All it can do is leak away its heat into space. As the years go by, it cools, until, in the end, it becomes a cold, black cinder. All stars succumb to gravity in the end. But it was only in the late 1960s that astronomers discovered what gravity was really capable of, when it had a star far heavier than our own Sun to play with. Deep in the dark Cambridge Fens, a trellis of wires and posts began to grow. By 1967, it was covering 4 acres, and that's when the regular signals started. This great array was our most sensitive ear on the cosmos, and on its chart recorders, it began to pick up strange messages from outer space.
Even as the paper was running under the pen, you could see the pen going whoop, 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 whoop. And it looked, even then, as if we were getting a series of flashes or pulses. And they were equally spaced at about 1 1/3 seconds. Incredibly fast for something astronomical.
Well, my first guess was that it had to be radio interference. I mean, we often get that. Motor cars drive along the road and upset the radio telescope, all sorts of things. But it was only when it reappeared several times in the same place that I had any faith that really it was an object worth looking at. At that stage, I thought maybe it was a flare star.
We spent the next 3 or 4 weeks trying to explain what man-made signal could be getting into our receiver and giving this, and we couldn't explain it. We then realized that the source of these pulses was miles away, way beyond the Earth, about 200 light years away, typically, which puts it outside the sun and planets, but within our own galaxy. We tentatively nicknamed it Little Green Men, because we were still hung up on the idea that it was human, mankind, man-made, and yet it seemed astronomical.
What Jocelyn Bell Burnell and Tony Hewish had actually discovered with their odd-looking telescope was another type of star corpse, but one even more extraordinary than a white dwarf.
They are called neutron stars, and they're incredibly dense. For instance, if one was to fill this cap full of neutron star material, it would weigh about 100 million tons. They're that dense. What we think happens is that when a big star reaches the end of its life, it explodes, as you know, the big spectacular supernova explosions. And the core of the star gets kicked against and shrunk in the explosion and turns into like a giant nucleus of an atom. And this star is spinning. We believe that the clock that drives the pulses is this spinning star. It's got a strong magnetic field, which is probably also important. By strong, I mean a mere million times the Earth's magnetic field that we use to point our compasses. And as this whole conglomeration of star and magnetic field spins once a second or 10 times a second or whatever, somehow or other, a beam is produced, a focused beam which sweeps round, a bit like a lighthouse here on Earth. And as it sweeps across us, we get a flash each revolution.
And because of their pulsing signals, spinning neutron stars have been given the rather more affectionate name of pulsars. Pulsars are like lighthouses in more ways than one, but the average pulsar will put a lighthouse to shame. While you might see a flash from a lighthouse perhaps once every 4 seconds or so, the average pulsar flashes several times a second, in fact 600 times a second in the case of the record holder. That's because what you're seeing is a spinning star with a hot spot on its surface, and every time you get in the beam of this particular hot spot, you see a flash. The other similarity between lighthouses and pulsars is that they're beacons in space. And we've already used pulsars as navigational beacons for our own extraterrestrial spacecraft already. The Pioneer space probes, which are currently leaving our solar system, both carry plaques to show where the probes came from. Each plaque reveals where our solar system lies relative to the major pulsars, a dead giveaway to any life form intelligent enough to travel in space. But could a space traveler visit a pulsar?
Well, I reckon a feather on a neutron star would weigh probably something like 20,000 tons. So a human being, you see, would weigh thousands of times heavier than that. So you wouldn't last long. You'd just get spread into a very thin smear over the surface in no time at all.
But where do pulsars come from? They too are star corpses, the centers of supernovae, huge stars that have blown themselves apart. Despite the superficial fireworks, what's really important is what's going on deep inside. Here gravity squeezes the core so tightly that the atoms get compressed into neutrons, forming a pulsar or neutron star. For example, the Crab Nebula is the remains of a supernova that the Chinese watched explode in 1054. At its heart, astronomers have discovered a pulsar, spinning 30 times a second. The star that exploded to make the Crab pulsar was 15 times more massive than our Sun. If an even heavier star explodes, it may leave behind a corpse that is more bizarre than we can ever imagine. A black hole, an object whose gravity is so strong that nothing can escape. It's bad enough trying to escape from the Earth's gravitational bonds. To do this, you need the thrust of a massive rocket like this one behind me. In fact, this is just one of the 11 boosters you need to push the massive Saturn V rocket to Earth's escape velocity of 7 miles a second. If you landed on the Sun and tried to make your escape from there, you'd really have to put your skates on, because the escape velocity from the more massive Sun is 400 miles a second. But the Sun and the Earth are nothing when you get into the league of collapsed star corpses. Suppose you wanted to escape from the surface of a neutron star. If that was the case, you'd then have to travel at half the speed of light. That's 90,000 miles a second. Is there any limit to this? The answer is there is, and it's all to do with compression. Just suppose I could take the whole of our planet Earth and compress it into a tiny globe about an inch across, like this. If that were the case, then its gravitational pull would go up so much that the escape velocity would rise to the speed of light, and our planet would become a black hole. Okay, that was pure science fiction, and there's no way that a fate like that could ever overtake a planet like the Earth, because it's nowhere near heavy enough. But even the most cautious scientist today believes that there are black holes out there. They're the ultimate fate of stars that are more than 20 times heavier than our Sun, the corpses of the most massive stars in the universe. What happens to a star like this at the end of its life?
Well, if a star becomes so compressed that gravity becomes totally overwhelming, then it can collapse completely, just shrivel away to literally nothing. And so it leaves a region around it which is empty, but it's also black because the gravitation is so intense, it even traps light as well as any other objects in its vicinity. So it's black and it's empty, and we call this a black hole.
One place you might look for such a beast is in a binary system, where the black hole is in orbit around an ordinary star. The gravity of the black hole is so great that it can suck material off the companion star and drag it down the hole itself, rather like water swirling down a plug hole. This material is so fiercely heated that it emits X-rays, which can be detected by satellites in orbit. Astronomers have now found a number of these X-ray binaries. The one most likely to be a black hole is called Cygnus X1. The bright blob in the middle of this X-ray picture is what we believe to be hot gas disappearing down the black hole. And what would happen if you were able to visit a black hole?
Well, there's this old speculation that you could travel through a black hole and come out in another universe. Well, on paper, this seems to be possible, but in practice, it seems as though it's actually exceedingly unlikely. It's a little bit like a drawing pin balanced on its end. We know such a thing is possible. In practice, it's unstable. It would just topple over. And now we know on the basis of theory that there are certain black holes which act like bridges or tunnels through into hypothetical other universes. But in practice, I believe that these tunnels or bridges would be closed off. They would be unstable. The slightest disturbance would cause them to shut off, and so there'd be no way through.
And what would you find inside a black hole?
Well, of course, a lot of people have wondered that. The first thing is that whatever it is inside a black hole, if you fall into one, you can't tell the people outside what you found, because black holes distort time in such a way that for you, it may take only a second or two to actually fall into the thing, but during that time, the whole of eternity will have passed by outside. So even if the people outside wait forever, you can't tell them what secrets you've discovered from inside the hole. But I think you're going to discover something pretty unpleasant. I think you're going to discover the end of space and time, literally the end of everything. You crash into something we call a singularity, which wipes everything out of existence. Every atom of your body, every last little vestige is extinguished completely and utterly at this singularity. So it is literally the end.
But there's another way of thinking about black holes. Might they influence or even change the future of our universe? To find the answer to that question, we need to look at the universe on the widest possible scale, at the most distant galaxies we can see. And that's just what Edwin Hubble was doing with this telescope when he made the most important astronomical discovery of all time, the fact that the universe is expanding and carrying the galaxies along with it. But will our universe continue to expand? That all depends on the amount of material in it. If there's enough matter, and therefore enough gravity, then the universe has effective brakes. These may one day slow the rate of expansion, bring the universe to a halt, and even reverse it. That means in the distant future, we might not belong to an expanding universe, but to a shrinking one. If the universe continues to expand, its future looks bleak. Slowly but surely, it will run out of material to make new stars and planets. In the far distant future, it'll become a cold and empty graveyard. But if there are enough black holes hidden throughout the universe, then their immense gravitational pull could halt and even reverse the expansion. The universe, then, would not run down. It would be reborn instead. But are there enough black holes to save the universe? To answer that question, we need to look back into the distant past. That may sound impossible, but the universe is like a time machine. Because the distances in deep space are so vast, the light from remote objects takes billions of years to reach us. So if you look at the furthest reaches of the universe, you can see what was going on billions of years ago. Astronomers suspect that immediately after the Big Bang, the universe spawned a generation of supermassive stars, stars which died as black holes long, long ago. These distant black holes could well dictate the fate of our universe. But will we ever be able to find the evidence that they exist? In order to look at those earliest moments after the birth of the universe, and to look for that first generation of supermassive stars, we need a telescope more powerful than any on Earth. And this is it, the Hubble Space Telescope, undergoing final preparations at Sunnyvale, California. It's one of the biggest and most sophisticated satellites ever built. Very soon, this telescope will be placed in Earth orbit by the Space Shuttle. High above our atmosphere, which ruins the view of ground-based telescopes, the Hubble Space Telescope will see further into space than any telescope has ever seen before. The light from the objects it sees will have been traveling through space for billions of years. That means it won't see them as they are now, but as they were a long, long time ago, very soon after the universe was born. So the Hubble Space Telescope will be able to look for the first generation of superstars, seeing them as they were billions of years ago, before they collapsed as black holes. If they do exist, it is the gravity of these stars, long since dead, that permeates the whole universe and ultimately controls its future. In our everyday lives, we hardly ever think about the stars. After all, from here on planet Earth, all the stars that have ever lived and died are very, very remote. And yet we depend on the stars for everything. We rely on one star, the sun, for all our everyday needs. And we have the stars to thank for our own existence. If it wasn't for generations of stars that died as supernovae and seeded space with the materials of Earth and the stuff of life itself, we just wouldn't be here. And there must be countless civilizations throughout the galaxy and beyond who live like us on planets with fertile land and oceans. But beyond that, the influence of stars is still more profound. For it seems that in the last resort, stars are all-controlling, even after death. The corpses of stars have powers that we are only just beginning to discover. those powers may enable them to save the entire universe.
Het boeiende verhaal van geboorte, leven en dood van Sterren beschrijft Heather Cooper samen met Nigel Henbest in dit boek. Verkrijgbaar in de boekhandel voor 44,50 of 890 frank. Dit was het voor de televisieserie, maar niet voor de radioserie. Daar volgen nog 4 programma's. Radioprogramma 6 over sterrenstelsels en groepen sterrenstelsels is woensdagmiddag om 3 uur op Radio 5. Bedankt voor uw aandacht en graag tot ziens. Nieuw op de maandagmiddag is deze serie vanaf volgende week om 5:45.